Our story begins billions of years ago, long before Earth existed. Imagine a vast cloud of gas and dust, stretching across unimaginable distances in the cosmos. This cloud, called a nebula, was the birthplace of our Sun and all the planets that orbit it, including our very own Earth. These nebulas are not just random clouds, they are the remnants of dying stars scattered across the universe. Within these clouds, tiny particles of dust and gas, the building blocks of planets, are spread out over vast distances, interacting with each other through weak gravitational forces. Over eons, these forces draw the particles closer, setting the stage for a cosmic dance of creation. The nebula that birthed our solar system was no different. It was a chaotic mix of hydrogen, helium, and heavier elements like carbon, oxygen, and iron, all remnants of previous generations of stars. These elements, forged in the fiery hearts of long-dead stars, would become the building blocks of everything we know and see. The story of Earth, a planet teeming with life and beauty, begins in this seemingly empty and chaotic cloud of gas and dust. It is a story of cosmic forces, chance encounters, and the incredible power of time. Within the vastness of the solar nebula, a drama of cosmic proportions began to unfold. This was not just any ordinary event, but the very beginning of a process that would eventually lead to the formation of our solar system. Gravity, the invisible force that governs the motion of stars and planets, started to exert its influence. This force, though unseen, is one of the most powerful in the universe, shaping the very fabric of space and time. As more and more particles clumped together within the nebula, their collective gravitational pull increased, pulling in even more gas and dust from the surrounding space. This process of accumulation was relentless, drawing in material from vast distances. Imagine a giant cosmic vacuum cleaner slowly but surely sucking in everything in its vicinity. This analogy helps us understand the sheer scale and power of gravity at work in the nebula. This is what began to happen to the solar nebula. The gravitational forces at play were so immense that they began to shape the very structure of the nebula itself. As the cloud contracted, it began to spin faster and faster, just like a figure skater pulling in their arms to spin more rapidly. This increase in rotational speed was a direct consequence of the conservation of angular momentum. This spinning motion further amplified the effects of gravity, causing the nebula to flatten into a swirling disk of gas and dust. This disk would eventually become the birthplace of planets, moons, and other celestial bodies. As the cloud collapsed in on itself, the temperature at its center began to rise dramatically. The heat generated was immense, far beyond anything we can experience on Earth. The immense pressure of the infalling material generated an incredible amount of heat, like the friction you feel when you rub your hands together, but on an astronomical scale. This heat was crucial for the next stages of star formation. This marked a turning point in the story of our solar system, the birth of a star. The conditions were now ripe for nuclear fusion to begin, a process that powers all stars. The core of the collapsing nebula, now a swirling inferno of heat and pressure, eventually reached a critical temperature. This was the moment when the nebula transformed into a protostar. At this moment, hydrogen atoms, the simplest and most abundant element in the universe, began to fuse together, releasing an unimaginable amount of energy. This fusion process is what powers stars and gives them their incredible luminosity. This event marked the birth of our Sun, a star that would bathe our solar system in light and warmth for billions of years to come. The Sun's energy would drive the processes that make life possible on Earth, and its gravitational pull would keep the planets in their orbits, creating a stable environment for the development of life. With the birth of the Sun, our solar system began to take shape. This monumental event marked the beginning of a new era in the cosmos, setting the stage for the formation of everything we know today. The remaining gas and dust that had not been consumed by the newborn star continued to swirl around it, forming a vast rotating disk known as the protoplanetary disk. This disk was a dynamic and ever-changing environment teeming with potential. This disk, extending millions of kilometers across, was where the planets of our solar system, including Earth, would eventually form. It was a cosmic nursery, nurturing the building blocks of future worlds. Imagine a giant cosmic pizza dough spinning gracefully around the central light and heat of a freshly baked pizza oven. This analogy helps us visualize the swirling, rotating nature of the protoplanetary disk. This pizza dough, the protoplanetary disk, was not uniform. It was a chaotic mix of different materials, with heavier elements closer to the center and lighter ones further out. This distribution of materials played a crucial role in the formation of different types of planets. Within this swirling disk, particles of dust and ice, remnants of the original nebula, collided with each other. These collisions were the first steps in a long and complex process of planetary formation. These collisions, initially gentle bumps and nudges, gradually built up larger and larger clumps of matter. Over time, these clumps began to stick together, forming the seeds of future planets. Over thousands of years, these clumps grew from microscopic dust grains to pebble-sized objects to boulders, and eventually to objects hundreds of kilometers across. This gradual growth was driven by the relentless force of gravity, and eventually to objects hundreds of kilometers across. These larger objects, known as planetesimals, were the building blocks of planets. The protoplanetary disk was a chaotic and violent place. It was a battleground where only the strongest and most resilient clumps of matter could survive. Collisions were commonplace, and only the strongest and luckiest clumps of matter would survive to grow larger. These collisions were both destructive and constructive, breaking apart some clumps while helping others to grow. Yet, amidst this cosmic maelstrom, the seeds of planets were being sown. These seeds, through countless collisions and accretions, would eventually grow into the planets we know today, including our own Earth. Section 4. From dust to pebbles, planetesimals form. As the protoplanetary disk continued to spin, the constant collisions between dust grains and larger particles led to the formation of even larger objects called planetesimals. These collisions were not just random, they were influenced by the gravitational forces within the disk, causing particles to clump together more effectively. Picture these planetesimals as cosmic building blocks, ranging in size from small asteroids to objects hundreds of kilometers across, similar in size to dwarf planets. These varied sizes played a crucial role in the diversity of celestial bodies we observe today. These planetesimals, held together by a combination of gravity and chemical bonds, were like magnets in the protoplanetary disk, attracting smaller objects and growing larger over time. The gravitational pull of these growing bodies became stronger, drawing in more material from their surroundings. As they moved through the disk, they swept up more dust and gas, adding to their ever-growing mass. This accumulation process was relentless, with planetesimals acting like cosmic vacuum cleaners, clearing their paths and growing steadily. Imagine a snowball rolling down a snowy hill, gathering more snow and growing larger with every rotation. This analogy perfectly captures the essence of how planetesimals grew, continuously accreting material and increasing in size. This is similar to how planetesimals grew in the early solar system, constantly accreting material from their surroundings. The more they accumulated, the more efficient they became at attracting additional material. The larger they grew, the stronger their gravitational pull became, accelerating their growth even further. This self-reinforcing cycle meant that the biggest planetesimals had a significant advantage in the race to become even larger. The process of planetesimal formation was a chaotic and competitive one. With countless objects vying for the same material, collisions were inevitable and frequent. Collisions were frequent, and not all planetesimals survived these encounters. Some were shattered into countless fragments, contributing to the chaotic environment of the early solar system. Some were shattered into pieces, while others merged to form even larger objects. These mergers were critical in the formation of the larger celestial bodies that would eventually become planets. Over millions of years, The number of planetesimals in the protoplanetary disk decreased, while the size of the surviving objects continued to grow. This gradual winnowing process led to the formation of the planets and other large bodies that populate our solar system today. Section 5. A growing giant proto-Earth emerges. Within the inner region of the protoplanetary disk, where temperatures were just right for rocky materials to condense, a particularly large planetesimal began to dominate its surroundings. This planetary embryo, destined to become our home, is known as proto-Earth. Imagine a game of cosmic billiards with planetesimals colliding and merging over millions of years. Proto-Earth in this cosmic game was a skilled player, clearing its orbital path and accreting more material than its competitors. As Proto-Earth grew larger, its gravitational pull intensified, pulling in even more planetesimals and gas from the surrounding disk. The process of accretion, while essential for planet formation, was far from a peaceful one. Collisions between Proto-Earth and other large planetesimals released tremendous amounts of energy, generating intense heat that melted the planet's surface. Imagine a cosmic bombardment, with each impact generating enough energy to melt rock and vaporize entire oceans. Despite the chaos, Proto-Earth continued to grow, eventually reaching a size comparable to Mars. Its surface, a molten wasteland scarred by countless impacts, held little resemblance to the blue and green planet we know today. Yet beneath the fiery surface, a process of transformation was already underway.